Series of 8th standard maths. Section 1, we will cover 5 chapters. I have grouped them differently than they appear in the book, but I have grouped them like this because this is going to make you understand the contents easier. That's what I felt, so I grouped them like that. So let's proceed with this, and we will cover the content. So the first chapter we will cover now is going to be numbers. So let's start the content. All right. So this is what we are starting with. This is the chapter 1 in this series, and this is the book we are going to cover. We are going to follow this textbook for standard 8 maths, and you can also get this book in epatsala.org, or also you can buy it yourself. I know all people who refer NCERT aware of this book for standard 8. Okay, now let's start with a brief about numbers. And as this is 8 standard, we will start with the proper grouping of the numbers. So first, let's see what is rational numbers. Okay. Now coming to the basics, what is a number first? Number is a mathematical object used to count, measure, and label. That's what the definition is. So it can be used to count, measure, and label. That's what a number is about. And as you go higher in your career, you will know that number is not just this numeric 1 2. Other formats of numbering also used. There are formats, maybe sometimes people start using ABCD also for numbering. Sometimes people use 1 2 3 not only in the way, or they also use in single I, two I, and all those Roman kind of nomenclature of numbers also use. So, but we are going to stick towards numeric numbers. More details. Numbers can be categorized differently, such as integers. So, is the way we are saying we are going to study rational numbers. So, let's see some background. So, numbers can be integers, and integers can be both positive and negative. So, you see here, it can consider 0, it can from 0 it can go to the positive side, 1 2 3 4 5, whatever it is, and it can also come to the negative side, -1 -2, like that. So first category is integers. Second, whole numbers. Now whole numbers are what? Whole numbers are numbers which excludes negatives. In the sense that it starts from 0 and all the way move towards the positive side, which is kind of 0, 1, 2, 3, 4, 5, all the way to n. And then next category is natural numbers. Now when you come to natural numbers means, okay, 0 is just a way of understanding or a tag, but 0 means 0, it is nothing, right? So in natural numbers it considers and starts from 1, 1 2 3 4 5, like that. And we also discussed there is another category which is negative numbers, um, and there is also a category called rational numbers, such as ratios and real numbers, such as square roots, and also there is a category called irrational numbers, such as pi and other terms. So we will study in detail what is rational numbers, what are ratios, what are real numbers called, and all those things in detail. Few more points to note here. Difference between integers, whole numbers, and natural numbers we already discussed here above. So that is something you have to remember. And then going forward, the most basic difference between whole numbers and natural numbers is that whole numbers include 0 and natural numbers generate for number 1 and therefore do not contain 0, that we already discussed. However, integers include numbers from negative infinity to positive infinity. Next content. In mathematics, the rational numbers are all real numbers. I'm sorry. In mathematics, the irrational numbers are all real numbers that are not rational numbers. We will get to this irrational numbers content gradually, but from understanding point of view, just consider that what is a irrational number, which is not a rational number. Examples as ratios such as pi of a circle circumference to its diameters. The square root of 2. These are kind of examples. So pi is a it's kind of okay. I will move on. The square root of 2 is also something that is considered as um, a kind of rational number. We will focus here properties of three types. Now that we know, okay, what is the categories of um, numbers such as integers, negative numbers, whole numbers, rational, irrational numbers. Now we will just focus three types in this chapter for our prime importance of understanding numbers, and we will gradually also discuss the properties of those numbers. So those three types are whole numbers that we already discussed, integers we already discussed, and then rational numbers, but we will discuss the differences in detail. Properties. So first we discuss, okay, what properties the number has, and we will discuss how differently these categories differ on that property. So per se, the first one is closure property. Now what is a closure property? If some arithmetic operation on two numbers of a category results a number in the same category, then that number category would be called closed under that operation. So it's a closure property. So if you do an operation on a category of numbers, it results in a number which also falls in the same category, then you say, okay, this number category follows closure property. Now let's see what is that. Now the operations are addition, subtraction, multiplication, and division. So now let's see. Let's consider whole numbers. Okay, if whole numbers we consider, does addition on whole numbers is satisfying the closure property? The answer is 0 plus 6, 3 plus 8. It again falls in a whole number. So the answer is yes. Yes, whole numbers addition operation satisfies the closure property. Integers also same. Okay, addition in with integers satisfies closure property. And then rational numbers also yes. Two rational numbers addition also satisfies closure property. Now coming to subtraction. Coming to subtraction, let's say whole number subtraction. Does it follow closure property? Because whole numbers are kind of 0 to positive, and if you do negative, something might go negative side. So that means it is not following the closure property per se. If you subtract a smaller whole number from a higher one, it becomes negative. So that's why it's not following. Integers also, integers does follow, because even though it goes negative, it's still an integer. And rational numbers, yes, it also follows, because positive, negative doesn't matter. Rational numbers are also following. Now, the next in this category is multiplication operation. Now, let's talk about multiplication. Yeah, it follows closure property. Examples we have given here: 0 cross 3 or 3 cross 7. Integers with multiplication operation, closure property, yes. Rational numbers also, yes. So multiplication on rational numbers is also a closure property. The way to understand it: first you understand the closure property definition, then you see, are these operations applied on these number categories, is following that property or not. Division. Now, in case of division, whole numbers definitely not following. Whole numbers will become ratios and fractions. Its a closure property is no. Integers also a no, and rational numbers also a no. Example is given here. When you divide 2 by 0, it becomes kind of a indeterminate situation, which is not a rational number. So that's why it is not following closure property. Properties continued. Commutative property. What is commutative property? An operation, a binary operation, is commutative if changing the order of the operands doesn't change the result. What is that? Let's see. Now, is addition commutative for whole numbers? Yes. If you change the operands, the result doesn't change. Same for integers, same for rational numbers. Subtraction. Subtraction, is it commutative? No. You change the operands, the result is different. Same for integers, same for rational numbers. Answer is no. Subtraction is not commutative. Multiplication is yes for all three categories. I have provided the examples here. Division is no. Results will change if you change the operands. So, no for whole numbers, no for integers, and no for rational numbers. Properties continued. Associativity. What is that? In mathematics, the associative property, is a property where rearranging the parentheses in an expression of a type of binary operation will not change the result. It's very simple. It's just a matter of putting the brackets and all. We will see this here. These are the operations. These are the number categories. What is associativity? So associativity, when you do addition, so per se A plus within bracket B plus C equal to within brackets A plus B plus C. So the brackets positions changed is called associativity. Now, even though the bracket position changes, the results are same, then it is following this associativity property. Addition, for addition whole numbers, yes. Integers also yes. Rational numbers also yes. They follow associativity property. Subtraction, the answer is no. You can see the examples. Results won't remain same by following associativity property. Integers also, the answer is no. If you change the brackets, the result should be different. And then rational numbers also, the answer is no. Multiplication, associativity property for whole numbers, yes. Integers, yes. Rational numbers, yes. You can see the examples. And then division also, it is no as usual. Associativity is not following for all three categories. Let's move. Some terms and concepts related to numbers. These things, if you remember, that helps. You may be knowing it already, but it helps to solve the problem. Few of them are: 0 is called additive identity for integers and whole numbers. Now, what is that? Additive identity. That means a plus 0 equal to 0 plus a equal to a. So this is called doesn't matter. When you add 0 to something, it gives the same thing. So it's called additive identity. Next, one is called multiplicative identity for rational numbers. Now what is that? Let's see example. 1 you multiply with a equal to a multiplied with 1 that equal to a. So that means, so you multiply 1 with anything, the same thing results. So it's called multiplicative identity. Next, negative of a number is also called additive inverse. So this topic is additive inverse. Earlier we discussed additive identity. Now what is additive inverse? It is a plus minus a equal to 0. So it's kind of inverse. That's why it is those two main and the inverse entities, when added they results in 0. B is called reciprocal of a rational number a if a multiplied by b equal to 1. So what is a reciprocal? That's a definition. If you multiply with a number with its reciprocal, it results in 1. Now there are more examples here we have given. Distributive of multiplication over addition and subtraction. See, um, so distributivity is working over addition and subtraction. That's the example it is giving. So you multiply a with the category of b plus c equal to same as this result, and so that's how you distribute. The expression is distributed when you multiply, and when you multiply a with b minus c, this is how it is distributed. Between two rational numbers, there can be countless rational numbers, unlike integers and whole numbers. So integers are kind of whole and very discrete kind of stuff. But in case of rational numbers, it covers ratios, fractions, everything. So and that can go any number. So that means between two rational numbers, how close they are, there could be countless rational numbers. The possibility in case of rational numbers is unlimited. So you cannot define between how many rational numbers are there between two rational numbers. Now let's have few examples and practices for better clarification or understanding. Okay, we discussed 0. 0 multiplied by half is 0. The next one is, what is 22 by 7? For 22 by 7, what is maximum number of digits in the repeating block of digits? So this you will know when you literally divide 22 by 7, and you need to calculate one by one what is the repeating block. Now what is that? Let's see. So if you see here, 22 by 7 equal to 3.22 by 7, by the way, is also called pi. And what's the value? It is 3.142857. Now this 142857 is repeating again and again. So that's what it says. What is the maximum number of digits in the repeating block? So that answer is 6. Because 142857 would be repeating. Those are 6 digits. Next one, simple operations. What happens when you add these ones and all? Clear? So first you do this one. Well, you can do any order, but I'm just giving you one example. You can do this one. It will gives you also operate on kind of similar groups. So the first category is giving you concluding to this, and then the following two ratios concluding to this. These are just stepwise solving how we are doing that. So that comes out to be 1 by 2, 1 by 12 here, plus minus 7 by 12, and you do the additions again, minus half. So this expression is after solving and doing all the operations reduced to minus half. So like this you need to practice a lot. There are many exercises, exercise 1, 2, 3, maybe many things there in the textbook. If you don't practice, you don't get the clarity. Okay, so this is all about numbers. Next topic is squares and square root. We will do it separately.